Hello, hello. So welcome to the live stream. So we are following a series in which I'm solving the blind 75 problems. Until so far we have solved 23 problems. So today in the agenda uh, I have to I have plans to solve 6 more problems. I have mentioned those problems or shared the names of those problems here: word break, course schedule, search and rotated sorted array, word search, product of array except self, binary tree maximum path sum. So these are most probably LeetCode medium tier problems. I am kind of deprioritizing LeetCode easy and LeetCode hard problems because LeetCode easy ones, like, okay, I want to cover them in one of the sessions, maybe in the last session of the series. And LeetCode hard problems, there is a less probability of them arriving at the interview, except for the few problems which are marked as LeetCode hard, but they are not actually hard. So yeah, let's start solving. Let's look into the first problem. Word break. Let me share my screen. Okay. So LeetCode number 139, word break. It's a LeetCode medium problem. Given a string S and a dictionary of strings word dict, return true if S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, so and okay, at any point of the time during the stream, if the voice is not clear, or if you have any questions, feel free to post it in the comments. I'll make sure to reply to those or address those. Okay, so in this problem, given a string S, so given a string S, that is in this example, if you consider LeetCode is the string given, and a dictionary of strings word dict. So and a word dict structure is given. That's the list of strings. There are multiple strings are given. Return true if S can be segmented into a space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, so the same word in the dictionary can be reused multiple times in the segments. Like we need to determine whether we can form this string S by using with the like with multiple words of this one. Like basically, yeah, basically, can we segment this to the words that are mentioned in this dictionary? So here in this case, in the LeetCode, there are two words in the dictionary called leet and code, and we can form LeetCode by using these words found in the dictionary. Here in the second example, you can see apple, apple, pen, apple, apple, pen, apple, and the word dictionary contains apple and pen. So we can form three segments: apple and pen and then apple. So we are reusing apple two times, but that is fine as they have given. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, in the third case, if we can see, there is cats, dog, sand, and cat in the dictionary. These are the words. And can we create this string using these words? So cats is there in the dictionary, and is in the dictionary. But if I use up and, then I'm left with OG. So OG is not in the dictionary. But what other way we can form cat, and then we can make the word sand. Sand is also in the dictionary. Cat is also in the dictionary. But the remaining word would be OG again. That is not there that is not present in the dictionary. So from the reverse direction, we can see dog is there in the dictionary, cats is there in the dictionary, Anne is not there in the dictionary. So there is no way we can form this string with this by connecting the segments of this words found in this word dictionary. That's why we are returning a false here. So when I look into this question, the thing that comes into my mind as soon as I look into this one is it should be backtracking, because like I'll be checking probably every word or a set of every character or a set of characters in this string, and then see if that is present in the dictionary. And then once we find one of the word, like our quest doesn't end there, we will have to continue looking into that string and solving it for the remaining characters. And we need to see, okay, leet exists, and then can we make the same way in the remaining or the rest of the word. Like for the code also, can we find something in the same way here? For this example, we will iterate to apple, and once we find one word apple, okay, next the problem would be sub problem will be like, can we solve it to pen apple, can we make those using the segments of the words found in this dictionary? So that's how we will solve it. So first thing that is coming to my mind is, I need to, like, again and again when I'm trying to see if this is a word found in the dictionary, I need to see if the dictionary contains this word. In order to do that using a list or an array, I need to iterate through all the elements in the array. Instead of that, if we use a hash set, we can do it and perform it in O of 1. That's why I'll try to convert that word dictionary into a hash set. So that will be a set of string. I'll name it as word set. Okay, and I'm just looping through this dictionary. Okay, okay, I added all those words to the word set. So now we can access them in O of 1. Now, as I mentioned, I'll iterate through the characters one by one, and as soon as I iterated in the first character here, L. Is that in the dictionary? No, it's not in the dictionary. L E, is that in the dictionary? No. L E E, no. And L E E T, that's there in the dictionary. Now I'll see, okay, the rest of the elements. C, is that in the dictionary? O, is that in the dictionary? D, is that in the dictionary? E, code is in the dictionary? Yes. Then I think I'll look for the rest, and the rest I'll return true. Okay, I'll reach the end of the index, I return true. And at the same time, if after leet, if the code failed for us, I could have checked leet C. If leet C exists in the dictionary, leet CO exists in the dictionary, in the same way. Like, let's say if the example was LeetCode only, not LeetCode. If the example was LeetCode, and then there was another word called LeetCode, then I check till leet. Okay, leet exists in the dictionary, and then okay, let me write what I'm saying. So basically, what if the scenario was like, LeetCode was the word that we want to find, and the dictionary contains LeetCode as well as a single word, and leet and code as well. So as soon as we reach leet, I would have said, okay, the dictionary leet exists in the dictionary. Now let's check for the remaining words. I would have checked that way only. For co, it since it does not exist, and then I would have not considered leet as a word, and I would have continued until the end of this string. Leet C, does that exist in the dictionary? No. Leet CO, does that exist in the dictionary? Yes. Now I would have returned it as true again. So how do we come up with the backtracking approach for that? So I'll create a recursive method for that word break. Let's call it as plain simple word break recursive, or word break backtrack, or something like that. And what all things are needed for us for that? In order to find that, I need the string which we are iterating through, and I need the index also, like which index I'm looking into. I'll start from 0th index, and then I need this set which contains all the words that exist in the dictionary, word set. And then what else do we need? Yeah, let's see. So as and when we come across any requirement, we can look into that. So let's see now. I'm defining this method, and that should return a boolean as well. And it takes in an int index and then string s and then a set of string word set. Okay, so now here what I can say is one of the okay, so another thing I need to say is the current start or the start of the word. So start is the index, but what am I trying to say? Like, do we need a for loop here, or should I just keep looping in using this word break recursive? That's what I'm deciding. Like, if we can use a for loop here, we can just get to the next word and see after that how we can do like call the recursive function, or else we can just call this recursive method one by one, just passing the index again and again. So let's see, let's use a for loop here for string for int I is equal to index. We are starting from the index, mind it. So we are starting from 0 in this case, but we are starting from index because this is a recursive method and we might reuse it. I less than s dot length, that is okay. We are traversing only until the end of the string, and then I plus plus. Okay, now let's see, if word set dot contains s dot substring of index to I plus 1. What am I doing here? So here I'm checking, okay, the current, like I'm iterating through this word. Let's say the word was pen apple. So this apple, pen apple. So if this was the word, let's say, okay, and then I is equal to 0. And then what do we have? Index is equal to, first thing is index is equal to 0, and I, we are initiating it as index, which is 0. And then word set contains all these values, apple and pen. Yeah. So now I have come here. So 0th index, I is equal to 0, I less than s dot length, string dot length, I plus plus. If the word set dot contains s dot substring of index to, index means it will remain at the start of whatever we passed here, index to s of I plus 1. So that means 0 to 1. So 0 to 1, that is a. Does that contain, does the word set contains that just a as a word? No. So what I'll do, I won't do anything. I'll keep going, and then index is equal to 1, index is equal to 2, index is equal to 3, index is equal to 4. So when we come to the 4th index, I'm checking from 0 to 5. From index value will be 0, I value will be 4. 4 plus 1, 5. So s dot substring of 0 to 5. So that would give us the word apple. So now I am checking, does the word set contains the word apple? Yes, it does contain. Yes, it contains that. So now what I'll do, I'll make a call to another, I'll make a recursive call to this function again. If word break recursive, and index will become, I'll pass the index as I plus 1. So I don't have to check till ith word. I have to check from I plus 1 word. Like I have to check from starting from P here. That's why I have passed it as I plus 1. And string will be the same. And then the set would remain the same. And what I'll do with this result, if that returns a true, then I'll just return a true directly. If that doesn't return a true, then what I'll do, I'll keep continuing. I'll keep going. If that doesn't return a true, I'll increment the index to 6. Apple P. Apple P, is that in the dictionary? Apple PE, is that there in the dictionary? Apple P and Apple Pen, is that there in the dictionary? No. So I'll continue that. Let's say Apple Pen was in the dictionary. So that would have been a valid case as well. That's why I'll keep continuing until the end of the string. So now, when does it return true? So now, if I say, if my words are starting from, you can see here, I did a word break recursive, and then this will call this called a recursive method here, starting from I plus 1 here, and then after 3 letters, okay, I find the valid character pen in the iteration of the following method. When I call this one, that calls the same thing, starting from index is equal to 5. So now the word, when I becomes I is equal to 5, we will start from I is equal to 5. When I becomes 8, we will start up, we'll have the word, this substring we would be is equal to pen. So now we will check if pen is there in the dictionary. Yes, it is there in the dictionary. Now I'll have to call the recursive method starting from 5, 8, 9. So that is the 8th index. So from the 8th index, we will call this one. So, and then once the apple, like once we found the apple in the next recursive call, it will call from the index plus 1, index plus, like at the length of this one, s dot length. So I can check, what I can check is, if there is a fresh call at index of s dot length exactly after this one, if there is a fresh call with nothing, that means we have found the match or the segments until the end of this string, and we are making another fresh calls. So with that assumption, we can return true there. So let's see, if index is equal to s dot length, so we are checking if index is equal to s dot length, then we can just return it as true. So if we are passing, if we want to start this word break recursive, starting from this s dot length, because e is s dot length minus 1, starting from after that one, that means we have found the segments until these characters. That's why I'm returning true here. If not, we will keep doing this one. Yeah, I think this should return true. If we cannot find anything until the end of the string also, we will return false here. So let's say if none of these recursive methods return true, that means, like for example here, cats and dog. Okay, cats and dog example, how does that work? Let's see. Let's replace this one only with this example. Okay, so here we have so we are starting with index 0, and then here index is not equal to s dot length. Okay, for I is equal to index, okay, word break doesn't contain index dot I plus 1, and it doesn't contain until the word cat. Okay, so cat is contained in the dictionary. So what I'll do, cat, that means 2, like 0, 1, 2. So index will be is equal to 3. So I'll make a recursive call, word break recursive call, starting from the index 3. And then I was 3 at that point of time. Okay, but yeah, it made another follow-up recursive call starting from index 3, and none of these things will change. And then it will keep going. S is 4, S is 3, A is 4, N is 5, and all those things are not in the dictionary, and D is 6. So sand is there in the dictionary, so D is 6. So I'll make another recursive call starting from the index 7, which is O, and then again I'll check O is 8, O is 8, and then G is 9, and then I'm not making any recursive call here, and I'll just come to the end of this thing, and I don't find anything here, so I'll have to just return false from the outermost, and then that cat's sand, that will only continue till OG, even that has to return a false. And this cat also, the initial one, that keeps going. That will figure out a cats as well actually. And then that will figure out a and also. And then it will return a false eventually with OG. So I hope this is understood. Let's run this one for these basic examples and see if it works. Okay, we can see for the base examples, it works. I'm not sure if I want to do any optimizations yet. Let me see. Let me check that one. Let's submit this and try. Okay, so the time limit exceeded for one of the use cases here. So we can see firsthand here. This is the use case, and we should ourselves, before the interviewer prompts us, we should think about this use case where you can see the string is a long string or long concatenation of a like repeated single character, and the word dictionary is the same thing. Now our question should be okay, and the expected output there. So we are not even sure about the expected output. Okay, it's pretty much definitely would be equal to true. We can make the segment of this string. It's made of AAA. Oh no, we don't have a B here. In any of these strings, we do not have a B, so it will be false. But in order to get that false, this A itself can go until here, and then AA can go until here, and then AAA can go until here. So what we can do is, in this case, whenever we return a false, whenever this one returns a false, before returning a false, I can, like for example, in this cats and dogs OG, cats and OG, this OG returned a false, right? Like for the last two letters, I didn't have anything, like it returned a false. And I repeated the same thing. Like initially I took cat as one segment, sand as another segment, cat as one segment, and sand as another segment, and OG as another segment. And I know that when I called for OG, it returned false. And next time I did sand OG, I continued there only. But that is a continuation. So that is fine for us. But here in this example, another example, I took cat, from cat I continued to cats, and then I took another word as and then I need to check for OG again. So I had computed for that index. Starting from that index, it would return false already, but I had not stored or preserved that result anywhere. So what we can do basic memoization, like in dynamic programming. So how to use that memoization? Let's see. Private. We can create a hash map. Like what I'll store based on the index. I'll store the result in boolean, whether it will return true or false. So that would be a memo. Okay, let's initialize that. Okay, I didn't create a separate constructor here. I just initialized it here only. Now let's see, I can use memo here. So if memo.contains key index, so this is the base case anyway. If index is equal to s.length, I'll return true as it is. If memo contains key index, then I think I can return from memo.get rather than trying to recompute it for that index. So memo.get index, and then here if word break, okay, so this one we didn't do anything here. Okay, here before returning, I can add it to memo.put. For this particular index, for the current index, I am returning it as false. I can return it as false, and then I can just do it as memo.get index. One more optimization that I am thinking of is, we are never gonna use the true command actually. Like if memo.get of index returns true, we are kind of bubbling up the true to the top, and we are returning instantaneously. If this returns true, the stack call, or the call that which made a call to this this method, that would return true immediately, and we kind of keep going up until the top level, and then this one will return true. So what we are doing is we need to store the false only in order to get value. So practically we do not need a hash map. We can just use a failed uh, use a set called as failed indexes or something like that. If this is the failed index, we can just return false. Otherwise we can just return true. That's or we can compute it. That's what we can do. But here, for more readability, I'm storing it as a usual memoization format. So let's see if this one would improve anything. Okay, so yes, yeah, I think this looks good to me. Let's run this one. Okay, we can see here for this case also it succeeded. It returned it as false. How did we do that? So once if we computed for this final index that is going to return false, I'm not going to compute it again and again. Final 2 also it knows it's false. Final 3 also it knows it's false. It will compute all these only once and then won't recompute. Okay, once we know that from this index it is going to be false, I'm not going to recompute once we come to this index. Or same applies to this one. Same applies to the segment till here. So since we compute only once, this is more performant and more efficient. So let's try to submit it and see if there are any other edge cases like an empty string or things like that. Okay, there's no. So this one works. So it's I think I had not solved this in a long time, but still I know the concept of memoization and I know the concept of backtracking. Using both of those, it was easy to solve. I just applied backtracking and it was a workable solution before, but it was not the most optimal solution because we were recomputing the same computations again and again. Now using the memoization, we stored the computation results in between, and then we were able to make use of that and do a better performance solution here. Okay, so this one works. Let's move on to the next problem now. So the next problem is course schedule. So if anybody has any questions, let me know. Okay, before moving on to the next question, let's see if there are any questions. Can you explain the memo part and why do we need that? Okay, sure. So let me go back to the code here. As I learned backtracking this week, I see some people use Boolean array named used and passed to the recursive function. Is that the same? Yes, it is the same. Uh, Saddam, basically what I am trying to do here is I do not need to know any, like I haven't even looked into the solution. What's the solution here? What I wanted is just the intent. Intent while working on the solution was I used backtracking and then I was able to get to the solution of the solution for the basic test cases, and it was working, but it was not performant. What was the edge case that we needed to figure out? So this was the kind of primary edge case. So basically this was not performant for this example because we can see those many words. So what will happen here if we take this many words and then our string is this one? Let me take it into our whiteboard also. Okay, so this is this problem, right? And our string is equal to okay. Okay, here the string is given like this, and then we have these words. which were represented this way. Okay, so this is the word dictionary and this is the string. Now, according to our approach, we will start iterating through this solution, and then once we encounter a single A, we see that that is existing in the word dictionary. Now we want to find if the if the remaining string starting from the index 1, if that exists in the word dictionary, if that can be formed using the word dictionary. And then again we will traverse one index, and then we will go through this things entire thing, and again we will encounter one, so we will go through these things. So this is one by one, right? And after that everything keeps fail. Like after we execute all this, we will execute one by one until this index, and then we see a B here. So B doesn't exist in the dictionary, and we will return it as false. Once we return it as false here, again it will take two characters. Like from A we will continue. Single A approach did not work. Let's take two A's here. Two A's is also in the word dictionary, and then we will approach it like, okay, 2A and then B. Okay, again B didn't work. That was false. And from here 2A, like from this index also it had recursion, right? Recursive call. Okay, we had taken 1A. Now let's take 2A, and then it will be followed by 1A again, and then a B comes, this will return false. I'm not sure like how many calls it might do, but it would be like in the order of at least more than 10,000 recursive calls for all these combinations. Like we need to check a single letter A, double letter A, triple letter A, four letters A out of these combinations, and we need to keep that doing again and again. After we take a 4-letter combination here, in the remaining one we need to check a single letter, double letter, triple letter, and everything. After taking a single letter also from this one, not just the single letter, we need to consider all the combinations: single letter A combination, double letter A combination, and all these letter A combinations. So that many recursive calls would happen. So how the memoization would simplify it? Memoization is simplifying in the sense that here once I execute something, once return something false for us. Okay, so here I come to the index. Let's say this was 99th index. This was 99th index. So I come to 99th index, and this is 100th index. Once I come to the 100th index, I compute it, and then I say that, okay, from 100th index, whoever comes here, it is going to be false. So just return false. So nobody bothered to check after the 100th index, it will be false. And then it will be the same thing for the 99th index. 99th index, it will check, it has checked for A and it didn't check for B, because from the 100th index anyway it is false. So it will return it as false from the 100th index. And this one also it will check from A, and it knows that from the 99th index also it had returned false because we have memoized that also. So it won't bother to check from the bother to call another recursion from the 99th index again. After considering a single A, it won't try to consider this another A as well. It knows that it is false and it will return directly false rather than trying to spin up more recursive calls. That's how this memoization call is being helping us to arrive at a more efficient solution. I hope this is clear now. And related to the data structure, how we use it, it's as per the developer's convenience. It should be like when I am the interviewer, I have conducted many interviews. Like I don't like I don't hold on an interviewer or interviewing about like what data structure he should use, as long as he has a proper reasoning to use as a particular thing, and as long as it is getting the work done, and as long as it is contributing to the readability of the solution. So readability is one most important factor, performance is one most important factor, and making it work is one of the important factors. So here I use, usually for memoization, I use a hash map. I told, right, in this example it does not make sense to save a boolean, because if it was true I would have just returned true. I'm not even saving it in the memoization or anything, because return true is always kind of bubbling up from as soon as I return true, we are returning true, and it bubbles up till here, and we end up returning true for the whole solution. So we don't need any intermediate storage. So why did I choose a hash map which stores the result of the function based on the index? I don't have to. I can name it as something like false result, false result indexes, or something like this, and then make it as a set. Okay, let me just show that for an example. Make it as a set, false result indexes and set of integer, and then let's say here we will have to call this. Okay, if instead of memo, I'll check if false return indexes dot contains, not contains key, contains index, then returns. So that means false return index contains means I'm just returning false here already. And then I'm checking instead of this one memo dot put false return indexes dot put index or add index. Okay, and then here I should just return false. I can just return false here since it is false, we know. Okay, and this one also I think I can just return false. Okay, if this contains, this can return false. Let's run this one and see if this one works as well. Okay, somewhere we have memo. Instead of this one, let's initialize a hash set. Okay, so now we can see sorry. Okay, let's forget this one. Okay, so here test case, we can see these 4 test cases and all of them succeeds with this set as well. So we should know how it works basically. How long have you been coding for? Okay, so yeah, basically you are asking, you are talking about a used array. Yes, we can absolutely use used array, but why I am not using used array is it is against me for readability, because I need to think about, okay, whether it will be a sparse index or like are am I checking for every single index or not? Like in this example, in this app, like AAA, here literally I will be having a failure case for every single index. So it makes sense to uh, use a used array or something like that, because for every index I'll be storing, and the array size should be equal to the index length. But let's say for this case, like this Apple Pen and all, we didn't store the result for every index. We might store the result only for particular index. Like for this cats and dog, we needed a failed result starting from this index. We didn't need it from the last index. We wanted it from the O, the index O, and then we wanted it from some other ones like and dog or somewhere. So in that case, we will, if we used a array list or a primitive array, and then if we try to use used, then there will be a lot of empty spaces or unused spaces. That's why I don't use it. That's why I prefer using a set or a hash map for storing those things. But there is nothing wrong. I would say if someone has understood that drawback and explains to me in the interview, okay, this is the downside of this one, I might use array. But most of my cases looks like this, where where I need to check every index, and then if they use it, I'm fine with that, as long as they know what they are doing. So yeah, so did I clarify what's the difference between using a hash set or a map or a used array or something like that? Okay, please. Thank you. So thanks for keeping it interactive, and please let me know if you have any questions also, or we can block some time if you have trouble understanding it again. So I'm okay to go over these problems. you can mark which problems you have difficulty with. We can go over it again. So in the interest of time, you can have specific questions. If you have specific questions, or if you have a specific problem, then I can explain it again. Yeah, now let's move on to the next problem in real. Uh, okay, LeetCode number 207, course schedule. So this is a LeetCode medium problem. Let's read the question. There are a total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites of I is equal to AI BI indicates that you must take course BI, you must take the second course first if you want to take the course A1. So we have to take this course first before taking this course as a prerequisite. For example, the pair 0 and 1 indicates that to take course 0 you have to first take course 1. Okay, so we have to take course 1 in order to take course 0. Return true if you can finish all the courses, otherwise return false. So from this one, all these dependency problems, we had solved one similar one like alien dictionary before. So there is some dependencies. I think the same, I have seen a similar problem for a build task, like our build tasks also use something similar, some similar logic. Basically, let's say if the package that we add as a dependency uh, is dependent on several other packages as well. So if there is a circular dependency, then we will have a dependency resolution somehow. Like, okay, the top package should have the dependency resolution by hard coding one of the package version name or things like that. Or else it will determine the dependency cycle, and then based on that it will add appropriate dependencies in our jar file when we are packaging the entire project. So how to resolve those dependencies, how to come like analyze those dependencies, basically that's the right word. Like in this case, we can use some kind of graph traversal as we used it in the alien dictionary problem. So how to, but they haven't given it in the format of graph for us. They have just given, okay, what are the total number of courses and what are the prerequisites. So this prerequisites itself is a graph for us. In order to take course 1, we must have taken course 0 before. So that means, okay, that is a dependency. So we can create a graph based on that. And here in the second example, there are two courses. In order to take course 1, we should have taken course 0. And here in order to take course 0, we must have completed course 1. So here, like we go, let's say there are two classes where we can register. When we go to register for course 1, they will tell you, okay, you should have completed course 0 by now. That's the prerequisite. And when you go to register for course 0, they will tell that, okay, prerequisite that is that you should have already finished course 1. So in that way, it's a cycle, right? Like, or a deadlock kind of situation. Like we won't be able to take either of courses because we keep revolving. And here in this case, let's say, okay, in order to like clearly they have said, in order to take course 1, we should have completed course 0. Then we'll go and register for course 0 and complete it, and then we will go to course 1 and register and complete it. So both of like in the order of, like, the order is 0 and 1, and we can take both the courses. That's why we are returning it as true. In this case, we cannot take either of those courses because both of them are dependent on each other. So that's why we are returning it as false. So now let's convert this prerequisites list into a graph format. So how to do that? So let's take a graph as usual, and then courses are given in the integer format. So integer as the key, and then list. Let's take a list of courses or list of prerequisites. In this example, only in order to take course 1, there, like, we had to finish course 0. Let's say if the example had like this, something like, okay, if the example was number of courses were 3, and then if we had 1 comma 2 here, Okay, in order to finish course 1, we should have taken course 0. And in order to finish course 1, we should have finished course 2 also. That means, like, in order to take 0 and 2, there is no information. 0 and 2 we can finish independently. There's no information or prerequisites mentioned. We can take either 0 or 2 first and finish both of them. Once we finish both of them, then only we can take course 1. That's the graph. So okay, so in order to, like, the graph format, why we need to take it to graph format is basically, we will be traversing as a, like, depth first traverse. Like, we know the graph traversals. So there are two types of graph traversals. One is depth first search and depth first traversal, and then breadth first traversal. So if we traverse through that graph, then we are considering each courses as individual nodes actually. Like course 1 is a node, course 0 is a node. So in order to traverse each of those courses, or in order to complete each of those courses, we need to make sure if we can traverse each of those courses without being stuck in a cycle somewhere. So that's what we are trying to see. And then in order to do that efficient traversal, we convert usually the data into the graph format. So in order to do DFS or BFS traversal, this graph traversal, graph format or the adjacency list format would help in a great deal. That's why we are converting it into a graph format. So this would be a list of integer. That means list of courses, or the list of prerequisite courses. Let's name it as prerequisites map is equal to new hash map. Okay, once we do this one, okay, so let's construct this graph first. For it is multi-dimensional array, so integer of array of integer array prerequisites. So I'm taking one integer array, means that would be a single prerequisite, and then I'm iterating through that using the iterator for each method. And then in a single prerequisite, so this will be, in order to be more readable, so the first coordinate will be the course name. So here we can see first coordinate will be the course name, and second coordinate will be the prerequisite course name. That is also a course, but that's the prerequisite course in this context. Let's take it as prerequisite course. Okay, this would provide more readable format. That's why I'm kind of splitting it one by one. So now we need to add it to the prerequisite map. Prerequisite dot put prerequisite first course, and then we needed to add for the prerequisite map, we need to add a hash set. So let's make this as a set instead of a list, set of integers, because we don't care about the order in which those dependencies are laid out there. So prerequisite map dot put if absent. For this course, if there is no set mentioned, then let's just create a hash set here. Okay, if that is already there, it will do nothing. And then what I'm doing here is prerequisite map dot get course, and then I'll be adding the prerequisite course into that one, to that set. So prerequisite map dot get course will return that hash set that is added for that course, and then we are adding a prerequisite course to that hash set. So that should create an adjacency list. If someone wants to see it, like how it is formed, then I think I can just execute it. Let's just return false as a placeholder. We can see here. So this should have a prerequisite map like this, right? Prerequisite map, like where one down 0, and then 1. Okay, 1 depends on 0 and 2, or 0 and 2 are the prerequisites of 1. That's how we will read this. and then that is not given in the question here, 3, and then I'm just adding our example here, 1 comma 2. So let's run this one. Okay, we know it's the wrong answer. We still haven't coded. Okay, prerequisites. I'm not printing the adjacency list of the graph there. So let's print this map. Okay, we can see here 1 is equal to 0 and 2. So 0 and 2 are the prerequisite courses for in order to take course 1. That's what we are representing here also. So now our graph is ready. Once our graph is ready, what we will do, we will have to iterate through each of the courses and need to make sure if we can finish all those courses. And then what information they have given? They have given there are total of num courses. So num courses means 2. So 2 means there is course 0 and course 1. And here also 2 means there is a course 0 and course 1. Here we have taken course 3. Num courses is equal to 3 means there is course 0, 1 and 2. So let's iterate through each of those courses. For int I is equal to, or let's call it as course is equal to 0 and course less than num courses. Let's do course plus plus. Okay, and for each of these individual courses, let's see if let's do a DFS traversal. DFS traversal of course. If that course returns true, let's see. Let's do a DFS traversal and let's return it as true. That let the DFS traversal return it as true if there is a cycle detected, or it should return false. If that returns a true, that means it's a cycle detected. Then we can just return it as false. Like we cannot complete this course if there is a cycle detected. So okay, if this DFS traversals returns as true, that means there is a cycle. Then we cannot finish all these courses. Then we are just returning it as false. Otherwise, we are iterating through each of these courses. And then if we are able to finish it, then let's say we can just return it as true. And then what other things we need in order to run the DFS traversal? So we need the course, and then we need the adjacency list as well, or the prerequisites map as well. Prerequisites map, that should be good. And also we need some notion of visited, whether we have already traversed a course. I mean whether we have already taken a course in general term. If you have to tell DFS traversal is nothing but, let's say, it means that we are actually taking the course. Let's say in order to do that, let's keep a visited set. So set of, so in order to, for the visited, in order to keep it like a proper format, like I think I was comfortable using it as like 3 values, like either 0, 1 or 2. Like 0 can be unvisited, 1 can be visiting, 2 can be visited, or 0 minus 1 and 1 minus 1 visiting, 1 is visited already, 0 is unvisited. Or else another approach I'll show is like just creating a enum for enum for it. So that would show our language proficiency when we are coding. But again, it should be okay. This won't be as performant as the other one, but we can try using that in this one. Visited status, we can say it, take it as visited, or we can start with unvisited and then visited and then visiting. Okay, these are the 3 different status. And then here let's pass here for each of the courses when we are iterating through, let's add that to a visited map as well. So visited map, how do we represent it? So it will be a integer to visited status. integer to visited status visited map is equal to new hash map. Okay, we can do this, and then here visited dot add course, and then we can just mark it as unvisited. Actually, in this case, I see that unvisited could be useless, pretty useless, but I'm just adding it. So let's see. Okay, we can correct it later if it is unnecessary or anything. So now let's define the DFS traversal method, and then let's pass the visited into this one as well. I'm just copying this signature, and then please let me know if my voice is breaking. Private, this should return a boolean true if there is a cycle, otherwise it should return a false. And then course is of the integer format, and then map of this will return a prerequisite map, and then this will be a visited status of the course. Okay, so now in this one, first thing first, let's do visited dot put for the course, which we should be like visited status dot visiting. Okay, now for let's iterate through each of the course in that prerequisites map. Okay, so now we have the course for in prerequisite. Okay, we will iterate through each of the prerequisites from the prerequisite map dot get course. Okay, and then what we should do, if like, okay, before that a course might not have any prerequisites. Let's say if we are iterating through like 0 or 2. 0 or 2 does not have any prerequisites, right? There is no information about that. So we can just complete it. So without having any cycles or anything. So in those cases, we can just return it as false directly. So what shall we do? So here, if prerequisites map dot contains key course, if it does not contain key course, then we can just return it as false without doing anything. Okay, and another thing is here, let's see, once we get into the prerequisites, if visiting status visited map dot contains key, if that contains key, prerequisite, this prerequisite course, and also if that visited map says that okay, prerequisite is still being worked on, visited dot get prerequisite is equal to visiting, then we can just return it as false owing to the cycle. Return it as false. That means there is a cycle. It is being revisited from another course as a prerequisite, and then intermediately in that DFS itself, if we encounter this one, we are never going to finish this. That means the same course is dependent on the same course at some point in the path. So that is a cycle. If not, what should we do? If not, let's run a DFS on this prerequisite. So if not, let's run the DFS traversal on this prerequisite course, and then pass the same things. prerequisites map and visited, and then if that returns true also, then also return false. If that also doesn't return true, then at the end we can just return it as true. Okay, so if there is a cycle, then we are returning it as true actually. So if there is a cycle, we should return it as true. And if none of these cycles are encountered, then we will return it as okay. Safely we didn't encounter any cycles, and we were able to traverse through all the courses. That means, and here also we just return false if the course is not contained in the prerequisites map. That means there is no cycle for that one. So I think this should cover most of the cases, at least as what I think. Let me see. Visitor.add course of unvisited. Cannot find symbol visited. So okay, visited.put it should be. Okay, it didn't work for us. So here we see 1 and 0 and 1 and 2. So this is the example that I had added. Let's add another example here, the original example, whatever was there, as 2, and then only this was there. And let's see if that works. Okay, even for that one it's failing. Let's see where it is failing. So 1 0 and 0 2. So I'm checking if the DFS traversal for a particular course returns false. Okay, then return true. And here also visited.put course, and okay, I'm just checking if there is no cycle, then I succeed. Okay, I need to mark it as visited also. That is another thing. Visited dot put course visited status dot visited. So I can mark it as visited. And also if this one contains key, or if it is already visited also, then also I can just return it as true. Visited.get is equal to visited status dot visited. Then I think I can just return it as false. Okay, but that's not the issue. I have made some obvious error somewhere. So let's check by taking this example only. We already have this example. So we have the prerequisites map, how it will be ready. And then we have a visited map. Let's troubleshoot now. Okay, in the visited map, we have the hash map, and I'm just taking it as visited.unvisited for each of the cases. So for 0, okay, for only I have added it for 0 for now. Okay, so and then I'm iterating through each of the courses. Now course 0, and then DFS traversal of 0, prerequisite map, and visited. And I'm checking here. Okay, I'm checking here. Here, visited dot put course of visiting. So 0 visiting. So 0 would become visiting now. Okay. So let me copy this here for easier access. Okay. So 0 will be converted to visiting, and then prerequisite, if prerequisite map does not contain key, it contains the key prerequisite map. Oh no, it does not contain the key 0. And then visited.get or visited dot get, okay, or if it's already visited. So this one itself is satisfied. 0 is not contained in the prerequisite map as the key. So I will just return it as false. So before returning it as false, I think I can just put visited dot put course visiting status visited. Okay, so this one is done and I'm returning false. So that returns a false for 0. Now comes 1. For 1, again we came here. For 1 I have added it as visiting now. For 1, for 0 I made it as visited. Now for 1 I'm adding it as visiting. Okay, for 1 visiting, and then 1 is contained in the prerequisite map, so this doesn't satisfy, and this also doesn't satisfy, so it will come out of this. And then I'm checking through prerequisites of the course 1. If visited dot contains key prerequisite, yeah, visited, yes, it contains key, and if it is visiting, then return true. Okay, here only, like I have just, okay, but this is for the prerequisite. So prerequisite is 0. Prerequisite is 0 now. So prerequisite visited contains key 0. Yes, it does contains key 0. And if that value is visiting, then returns true. Now its value is visited already, so it doesn't return true. It will skip to this one. Now I'll do DFS traversal of prerequisite map and visited, and then if that returns true, I'll return true. But for 0, since it's already visited, it should come here. It's already visited and it should return false only. So this would return false, and it won't satisfy, and prerequisite will be 1. So for 1, again we visited dot, it does not contain the key itself, doesn't so it will just return go out of this one, and then I'll be doing DFS traversal for 1. So it will come here. First thing is it will add it as visiting for 1. Sorry, that is for 2. For 1 we are done. So for 2 we will add it as visiting. Okay, for 2 visiting, and then for 2 also there are no prerequisite. 2 is not contained in the prerequisite map. So it should return false. It will return false. And then for 2 also we returned false. And both the prerequisites are done for 1, that means. And it will mark this one also as visited. And this one also as visited before only. Okay. And then we are just returning, okay, put it as visited, and we are returning false. We return false for the DFS traversal of 1. For 2 also, as soon as we come, again it will check that we have already visited, and then it will return it as false. So if DFS is returned as false for all those 3 courses, then it should return true. Then why is it not returning true? Okay, actually it's working. Why did I assume it's not working? Because there was compile error, I guess. Okay. Yeah, when we traced it, that's why we didn't encounter any error. I didn't notice what was the error. Yeah. So, yeah, but I saw some error before. Okay. Uh, Whatever it is working for all these 3 cases. Let's submit it and see if there are any hidden cases. Okay, if the number of cases or number of courses are 100, it's taking a lot of time. So Okay, here. Let's do this one. If visiting dot get course of visitors. Okay, if this one is equal to visiting, then return true. Now another thing is, if it is already visited, then just return false. Okay. Took a long time, man. So it was a silly mistake actually. So we see here, I think we should learn from our mistake. So here I was putting visited dot put of visited, and then I was making a visited check here in the original method. Like if it was visited, I was not calling this reverse DFS traversal method. But this one happens only when I call through this course one by one. Like when there is a disjoint set or when there is no dependency of the courses on one another, then it will initialize from here. But if there is a dependency, if one course is a prerequisite of another, then we keep calling from here only in depth first search, and then we will try almost we finish the traversal of all the courses around here. So once I marked it as visited, I had to check if it is already visited, then just return it as false. Don't do anything. I was not doing that. So now I added it as just like when it is when it is marked as visited, then just return it as false. And if it is marked as visiting, and then if I'm trying to visit that once again, that means there is a cycle. The same course is dependent on itself, so it's never going to finish. That's when I will return it as the cycle detected, and I'll return it as true. So this one is okay, already visited, so I'll just return it as false. So that works for this course number 100, I mean 100 courses as well. So let's submit this one as the final thing, and it works now. Okay, so like we should be mindful first thing. I think that was bad of me not being mindful of using all the constructs that I had defined. I had used visited, but I think the main point where I got confused was I had used it in this original method, and then I removed it because it was insignificant here. I wanted to use it down in this method, in the DFS traversal method, but I ended up forgetting that, and I just was checking the visiting status and then was looking into the cycle, and I never bothered about just returning it as false if it is marked as visited. Then I don't have to do this all these things again, or all the traversal and everything again if it is already visited. So that was the optimization. We will just visit each of the nodes only once. We don't keep repeating that. Okay, so that concludes it. That took quite some effort from me. So okay, let's hit the road again. So we solved two problems before the break. So now let's solve two more, and in the next and let's take a short break again, and then after that let's break two more. So we'll be done with 6 problems for this session, and then let's end the stream. So for the next 2 problems, these are one of the important ones. So let's address the next one. Lead code number 33, search in rotated sorted array. So this is a lead code medium problem. There is an integer array nums sorted in ascending order. Note that it is sorted in ascending order with distinct values. There are no same values. Prior to being passed to a function, nums is possibly rotated at an unknown pivot index. So it is sorted, but it is rotated as well. K is equal to at some point, such that resulting array is okay. At some point it would have rotated like this. Like let's say this is 0, 1, 2, 4, 5, 6, 7. If that was the case, it was sorted, but it is rotated by 4 elements. So it became like a sorted starting from this index and the rotation. So that's the condition now. For example, 0, 1, 2, 4, 5, 6, 7 might be rotated at pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. Okay. Given the array nums after the possible rotation and an integer target, return the index of the target if it is in the nums or -1 if it is not in the nums. You must write an algorithm O of log n runtime complexity. So we all know if there is a sorted array given, then using binary search we can find any element in a sorted array in O of log n time. But here there is a twist. The array is rotated by a pivot. So if in order to accommodate that, we need to make slight modification to our binary search approach. So how do we do that? Let's check multiple different conditions. Like let's say like how do we perform binary search? We will usually take int as one index as left and one index as right. So right index will be pointing to our rightmost character. So that would be nums.length -1, and the left pointer would be left index would be pointing to the 0th character. So and we have the target that we are looking for, that is given. So now let's see here, while left is less than or equal to right, we can keep going. Okay. And first thing is, in binary search, what do we figure out? We need to figure out a mid value. So let's figure out the mid index. So mid index will be left plus right minus left divided by 2. So this is like left is 0 means left is 0 and nums.length -1. Let's say this is the example. Nums.length is 7 and nums.length -1 6. So 0 plus 6 minus 0 divided by 2. 6 minus 0 is 6. So 0 plus 6 by 2, so that is 0 plus 3. So that will be 3. So 0, 1, 2, 3. So the 7 will be the value in the mid index. So mid is the index. So 3 is the index. So that is pointing to the number 7. So now what should I do after we have a mid value? So let's do the first thing. If we find the answer, there it is. If nums of mid, if that is equal to target, then let's just return it. Then let's just return it as integer. We need to return the integer of, I think we need to return the index here. So given the array nums possible rotation, return the index of the target. That's what they have asked. Okay, let's return the integer index as mid. If not, let's check two cases. One of the cases, if like we need to figure out if the left of the mid is rotated or if the right of the mid is rotated. So how do we figure out that? If the left of the mid is let's see, if the left of the mid is not rotated. Okay, if it is not rotated, okay, left of the mid is not rotated, that means the first index in the left will be less than or equal to or less than the last index before mid, right? So what shall we do here? So if num set index num set left is less than num set mid, then that means the left of the mid is not rotated. Okay. Else, but we know that one side of the mid is always rotated. So we can assume that right of the mid is not rotated if this is the case. Okay. If now we know that the from this one we are checking if the left of the mid is not rotated, then we can make some like if that is not rotated, we can have some clear conversation with that. So based on the target that we are looking for and the values that are on the left side of the index or the left side of the mid index. Okay, now what we will check? So now we know the target value and we know that the left side of the mid is not rotated. So what we will check is uh, if uh, if a target is less than nums of mid and target is greater than or equal to nums of left. Okay, so that means it is in that range, right? It is in the range of the left half portion. So then what we will do, we need to reduce our like we need to start looking at the left of the mid portion. In order to start looking at the left of the mid portion, we won't modify left, we will keep the left as it is. We will make the right as mid minus 1. Then we will start looking into the into all the elements starting from left to mid minus 1. If that's not the case, then we will make left is equal to mid plus 1. That means we will be looking into the other side of the mid for the target. Now the opposite condition. Okay, in other case, if let's say if the left was rotated, left of the mid was rotated, if we know that the right of the mid is not rotated, then we will try to talk reasonably with the right of the mid elements. Then what we will ask, if again the similar thing, if target is less than nums of right, less than or equal to nums of right, it could be equal as well, and if target is greater than nums of mid, we are not checking greater than or equal to because we already checked for the equality with the nums of mid here. If that was the case, we would have returned it anyway. So that's why I'm not checking for equality with nums of mid here also or here also. If that was the case, if target was in between the right element and the mid element, then our left would have become left is equal to mid plus 1. Okay, right would remain same. Otherwise, our right would become mid minus 1. And that means we will look into the other side of the mid. The target doesn't exist on the right side of the mid, so we'll look into the left side of the mid. That's why we are modifying right is equal to mid minus 1. Okay, so that should do it, that should do the trick, and we will do it until the left is less than or equal to right. And until then, if we don't find the index, that means we will return it as minus 1. That means the target is not found. Let's run this one for the base test cases. So it works for all the test cases. Let's submit it and see if there are any hidden ones. Okay, we see here for 3, 1, the target is 1. And I'm giving the output as minus 1, but the expected is 1. Okay, so here okay, here I'm checking nums of left is less than nums of mid. then this side is not sorted. So nums of left is okay. Okay. So now I consider that left case also. Okay, let's say if this itself was the left, like if it was one element we are searching through, one element segment that we are searching through, then mid is same as the left side of it. So need to check for that condition as well. So now it works. So let's run through this example, run through this case with one of the examples to make it more clearer. This is okay. I'm considering this example. Okay, and let's take left is equal to 0 and right is equal to, we have initialized left as 0 and right as num dot length minus 1. So num dot length is 4 plus 4 8 minus 1 7. Okay, now mid is equal to, we are checking if left is less than or equal to right. Yes, mid is equal to left plus right minus left divided by 2. Right minus left is 7 minus 0. 7 minus 0 divided by 2 is 3.5, that is 3 in integer division. 3 plus 0 is 3. So mid is equal to 3. So mid is 0, 1, 2, 3. Mid is pointing to this element. So now we are checking if, and the target, okay, I don't know the target. Target is 8. We are looking for a number 8. Okay. So here let's go. So we know the mid is 3. Now we are checking if nums of mid is equal to target. Nums of mid is 7. It's not equal to target. Then we won't return it. Now we are checking if the left side of the mid is not rotated or not. So if the left side of the mid is, actually left side of the mid is not rotated, but the right side of the mid is rotated, right? We cannot come to a reasonable conversation with this one. Like we cannot have a reasonable conversation here because the first element is greater than the last element. So how can we assume that this is in the sorted order? So we cannot make any binary search decisions based on these values. So now we concluded here. How do we check that left side of the mid is not rotated? If the nums of left is less than or equal to nums of mid, nums of left, which is 4, if it is less than or equal to nums of mid, which is 7. So that means 4 is less than 7, right? So all these are in sorted order. So we assume, we know that the left side of this one is in sorted order, it's not rotated. So now we are checking if target is less than, we will check basically if target is in between these values. If target is less than nums of mid, if it is less than nums of mid and target is greater than nums of left, if it is greater than nums of left, then what we will do is we will try to search within these elements. How do we do that? Then we will make the right as 2 only, like 2, like right as mid minus 1. But this is not the case. We are looking for 8 here. 8 is not less than 8 and 8 is greater than 4 but 8 is not less than mid, so it doesn't satisfy this condition. So we what we understood is, even though we are not looking at the left side, what we got is we need to look at the other side. We don't have the element here. That's what we were able to conclude. So what we did is we incremented left to mid plus 1. So left became mid plus 1. So now our new search space is these elements, these 4 elements, starting from index 4 to index 7. So now what we will do? So now left became, we modify the left as mid plus 1, which is equal to 4. So now again, mid is equal to left 4 plus 7 minus 4. 7 minus 4 is 3. 3 by 2 is 1. 4 plus 1, 5. So mid value became 5 now. So if nums of mid is equal to target, yes, nums of mid is equal to target indeed. So we are returning the mid value, which is 4. So that will be returned here. So we can see that the mid value is returned output as 4. So that's how this works. Like we we do not have both the sides as sorted, but we will know that one side of the mid will be sorted, and we will try to have a conversation with the elements of that side, and based on that we will modify our left and right indexes. So that should be clear. Hi, Shekhar. Hello. Explore your channel and content is excellent. I have seen system design playlist. I'm beginner, so please create a one short full video on object oriented principles and solid principles. Yeah, Shekhar. Thank you for the feedback. I'll add it to my list of things that I want to make videos on. Solid principles and object oriented principles. Thank you for the feedback and thanks for watching. And Soban, welcome to our live stream. Today I saw you for the first time. So, and you have been nice. You're being nice to me. Yeah, thank you. Please let me know if you have any feedback, or if you are looking forward to any particular content. I can go over that. And Better Daily has a comment. This question is off topic, but how long did it take you to get comfortable with coding? Because I'm having trouble right now. I think uh, I don't think I have improved on my coding skills since past maybe 8 9 years, I guess. So I was doing, or I was solving the problems the same way when I was in college. It's all about practice. Like if we are into that, or if we are in that zone for an year, or little over an year, then I think we will get that muscle memory. Before that it's hard. Like we will be able to code, but before an year it's hard to implement everything that we think about. Now at like after coding for an year or so, then our condition will become like, okay, we know the solution for the problem. I mean, logically we will be able to translate that to the format of code in the language that we are comfortable with. So I hope that answers answers your question. So like you can assume it would take, definitely it would take an year at the least, in an year of continuous dedicated coding. It's not like we code for a day and then we come back after a week or two and then we will try to code one more thing. It doesn't work like that. We need to be in that zone at least for some time. Then I think we can get really good at it. And for me personally, yeah, I have been coding for a long for a long time now. So yeah, so this is expected basically from anybody who codes for that amount of time that I have coded. I mean, they will be at least as comfortable as I am. So, and Shekhar, yeah, thank you for the feedback. I'll keep that in mind. I'll make sure to add that in my notes at least so that I don't forget. Yeah. Let's move on to the next problem now. Next problem is word search. Okay, we are in another graph related problem now. Okay, let's get to that. Okay, so this is LeetCode number 79, word search. It's a LeetCode medium problem. Given an m cross n grid of characters, board, and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. Okay. So as I think this picture is clear, but if we are asked the same question in the interview, there I don't think there will be a visual representation of this thing like as neat as this one. But yeah, we can see from here, read from here. Given an m cross n grid of characters board. Okay, a board is given with characters and a string word, and a word is given. Okay, characters are given, I mean board is given and a word is given. Now we need to return true if the word exists in the grid. If the word exists in the grid, and how to check if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells. Sequentially adjacent cells should have those letters. Then that means the word exists in the board. Where adjacent cells are horizontally or vertically neighboring. So it should be horizontal or vertical neighboring. It cannot be diagonal. So every cell will have 4 neighbors. We can just check in those 4 directions. Okay, the same letter cell may not be used more than once. Okay, same letter, like let's say if it is A, B, C, C, E, D, that's the word, right? We couldn't have used the same letter for multiple times. We have 2 C's explicitly. We need to have 2 C's explicitly in order to make that word. So this is like, I think this reminds me of number of islands problem. So in the number of islands problem, we had similar graph representation. We had to keep traversing uh, through that multi-dimensional array and figure out how many islands existed. So in this one also, this includes some traversal, right? Like we can keep going through each of the cell in this on this board and see if we encounter the first letter in that word. If we encounter the first letter in that word, then we can start traversing across its neighbors. And then as long as we find the next letter, then we keep going. If we don't find the next letter of the word among its neighbor, we can just return it as false and we can move along. We can, like, let's say I checked with, let's say I started by checking with the neighbor below here. After S is there, S is not equal to B. Then we just backtracked, we saw here. And then we looked into the neighbor here, which was the left side neighbor of A. But that is not a valid neighbor, so we just backtracked here. And then we looked into here, and then that is not a valid one. We came back here, and then we looked into the right side neighbor. And here, same thing, B, okay, B matched. Okay, now we will start from here and we look for the next character, and then C, okay, C found. So next character, okay, here, okay, C is not there, it's E. Okay, we didn't find it here, we will come back here. We look into the other neighbors. We cannot go back to B because it's already visited. Let's keep a notion of visited here also. And this is invalid on top. So we will enter it to the bottom neighbor. So that is C. Okay, we found that C. Now we need to look into the next neighbor, and we found E and D at neighbors only. So how to go about traversing this one? This one is also DFS traversal only, because once we find one of the element, we are going in deep into that neighbor only. It's not like we will check for all the B's existing at this level or all the C's existing in this level. We won't do that. We got a C, and then we are looking into, okay, is there one more C? And then we are looking into, is there a D as a E as a neighbor? So we will try to look until the end if the word is found. If the word is found, we will return it as true. If it's not found, we will look into the other neighbor probabilities. Like from C, like we checked on the right neighbor, we checked on the left neighbor, E is not found, and then we looked into the bottom neighbor. So yeah, if this is not found, it return false. This is not found, this return false. And then we saw here, okay, then E didn't return false. So we kept on doing the DFS again. DFS with E with modified index value. We are looking for the last letter D here, and we found that one. So let's keep going now. This is a matrix problem. So it's a bit tedious in order to keep track of all the indexes and things like that. So let's try to be as elaborate as possible. So int m is equal to board.length. Let's take it as board.length for now. And int n is equal to board of 0. So this will increase readability for us only without costing any runtime, any additional runtime. So these kind of things, these kind of small things. And then how do we go about iterating through each of the letters in the board or each of the cell? For that, int I is equal to 0 and I less than m I plus plus. Let's do that. And then for int j is equal to 0, j less than n, and j plus plus. Okay, now we came across all the we will come across all the cells in the board. What we will do is int or char current char is equal to board of I comma board of J. So that would be the current char. So now what we need to check, as we saw when we are iterating through, if we find the first letter of the word, then we will iterate. And then let's check if the word dot length is equal to 0, then just return it as false. Then we can just return it as true, the word. Okay, and here we need to check the first letter of the word, right? If word dot char at 0 equals current char. Okay, if that is the case, what should we do? We should do DFS traversal or DFS search for the rest of the part of the word, DFS traversal. And how we will conduct the DFS traversal? We will pass the index. Index is 0th index, and then we will pass the index is 0th index in the word. I meant not in the board context, but in the word we are starting from 0th index, or we can start from first index because we already compared the 0th index also. So let's start from 0th index to be safer. And then I is the index in the this one, index on the board. I and J are the indexes on the board, and then we need to pass the board also. And then let's pass another array called as visited. So that should be good for now. And what should we do? If DFS traversal of this one, if that returns true, then we will return it as true. If that returns false, we won't return it as false immediately. If that returns true, we will return true. Like let's say I started from A here, and then I started DFS travels, and then DFS traversal itself returned true to me. So that's why I'm returning it as true. What if it had returned false? Let's say in the second use case, here I'm looking for the word SEE. So I traversed to A. Okay, from A the character was not there, and B there was nothing, from C there was nothing, from E there was nothing, and now here at S I found the first letter, right? And then I would do DFS traversal. But DFS traversal doesn't return true for me. That's why I won't return false. I will keep checking for the next letter here. From this one I check, from this one I check, and from this S letter I do the DFS traversal again. This returns true, then I would return true. From this S, even though the DFS traversals return false, I won't return it as false. That's what I wanted to clarify. So now let's keep going. DFS traversal, I have added a method, and I have added when I'll return it as true. If none of those characters or none of the searches DFS traversals returned a true value, then I will return it as false for the entire thing. Now let's implement the DFS traversal. And visited. So visited, I haven't defined visited. So visited will be boolean of visited is equal to new boolean array of, it will be same as m cross n, same dimensions as the board, to see if the cells are visited or not. So private boolean DFS traversals, and then here int 0 is the index. Okay, and then here int I think we can keep I as it is, and then int j, and then board is character array of board. Okay, and then visited is boolean array, boolean multidimensional array, that is character multidimensional array. Okay, so this is our method DFS traversal. Now what should we check here? So here first thing is, like at this index, whatever the character is there, that should be equal to the character on the board at I and j. So if that is not the case, we can just return it as false. And also we should, before that we should check if I and j are valid or not. So if is valid I comma j comma board, if not valid, I mean, then we can just return it as false. Okay, let's define when it is not valid. So for that, private boolean. Okay, let's define this method is valid. This will be an integer, this will be an integer, and this will be character multi-dimensional array. Okay, so when I is less than 0, it's not valid, right? Or if j is less than 0, it's not valid. Or if I is greater than board dot length, or greater than or equal to board dot length also, then also it's not valid. Or j is greater than or equal to board of 0 dot length, then also it's not valid. So okay, return I is greater than I just listed down the invalid cases, but I need to return the valid cases. Otherwise, I need to look into the negative things. Like let's see here. If I is greater than or equal to 0, then it's valid. J is greater than or equal to 0, then it's valid. Or I is less than board dot length, then it's valid. J is less than board of 0 dot length, then it's valid. Then I'm returning it as, and instead of R, all these conditions should be satisfied. Okay, if I is greater than or equal to 0, j is greater than or equal to 0, and I is less than board dot length and j is less than board of 0 dot length, if all those conditions satisfied, then I and j are valid. So if I and j are not valid, I'm returning false then and there. If they are valid, then I'm making another check. Another check is if visited of I and j is equal to true, then also I'm just returning it as false. If I and j is already visited, then I'm just returning it as, I'll just return it as visited of I comma j. Okay, now after that is done, another thing is if char or board of I comma j is equal to, okay, another thing is we forgot to take the string or the word itself as a parameter. We do not have access to that. Let's get that before this, or as a second parameter only. Okay, so string word. Okay, so now let's do here int or char current char is equal to word dot char at index. Okay, if board of I comma j not equal to current char, then we can just return false. If it is equal to current char, then what should we do? We should mark it as, first thing is visited of I comma j, one of those indexes, is equal to true. It could be like a circle, right? Like if we are coming from here, let's say A, B, C, E, D, and then we could have gone to this one also. But if we had used something like, if we check here and then come here, then I mean, how to explain? Okay, let's say if I'm coming from here, let's say I started from here. Okay, if I'm coming from here to this one and then this one, even that would make a word, valid word. Okay, but if I'm coming here, I should know that this index is already visited. Then I cannot consider that twice. But this index will still be open. I can just still go like this. So for that reason, I need to add it as visited of I comma j is equal to true in the beginning. But that is for one of the DFS only. For the next DFS, again, I should mark the visited as false. So after this DFS is done, I will mark the visited of I comma j as false. I hope you understood why I am marking it as true and false within the same one. In between that, I will make more DFS calls. So visited of ij is equal to true. And then what else do we need other than that? Other than that, okay, I need to check if now here I established that the current character is equal. Current character and ij, like whatever the character in the index and whatever the character in ij are equal. Now now it's time to look into all the neighbors of the in the board, all the neighbors of ij. So how to look into all the neighbors? Let's see the directions. Let's take a integer called as directions, integer array called as directions, just to make it more readable. So this will be like new int of zero comma 1, 1 comma 0, 0 comma minus 1. So these are the directions, possible directions, and minus 1 comma 0. I hope this syntax is correct, but if not, maybe like this. But yeah, if not, I'll come back to this one. So all I wanted to do was to save 4 directions possible, or 4 possible neighbor directions. So 0 and 1, if I add 0 to I and 1 to j, and then if I add 1 to j, 1 to I and 0 to j, if I add 0 to I minus 1 to j and minus 1 to I and plus 0 and 0 to j, then I'll get all the 4 neighbors. So what I'll do here is I'll iterate through all those directions. Direction from directions. Okay, if DFS traversal of, what am I traversing with now? So if DFS traversal of index, now I will pass another index plus 1 now. Index plus 1 instead, and then word I'll pass as it is. I'm passing index plus 1 because if the first letter is already equal, then I'm checking for going to check the second letter, which is B here in this example. So for B, I will have to pass the neighbor indices. So neighbor indices, how to get that neighbor indices? I plus direction of 0, and for j plus direction of 1. So that is about I and j, and then board will be as it is. I'll pass it as it is, and then visited, I'll pass it as it is. I have just populated that visited is equal to true because I've already visited in this DFS. But once all the neighbors are visited, and if I don't find it, I'll mark the visited as false in case if I'm traversing from some other neighbor again later. Like for example, from S, if I had found only one E, then I would have marked it as visited. But again, if I didn't find all the elements after that, I would have marked it as not visited, so that from SEE I can come and mark it as visited later. So let's see here. Here these things are done. Okay, index plus 1 word. Okay, I'm checking all the directions, and then I'm seeing if DFS traversal of all these things returns true, then return true. Otherwise, keep checking in the other neighbors. If one neighbor doesn't return true, that means we don't have to return false. We can check in the other neighbor, and then once all the neighbors are done, we will just return it as visited as false. We will mark visited as false, and if we did not return true anywhere there, we'll return it as false. But when we will return it as true, we didn't mark any such positive conditions here. When we will mark it as true. So let's see if we come through each of the character without returning false anywhere, And then if we reach the index which is greater than the word length, that means we have found all the other words or all the other characters. That's when we came to the graduated to the next character. So when I'll do that, I'll check that when index is equal to word dot length. Okay. And okay, I don't have to do anything. Okay, our index is equal to, I can just check index is equal to word dot length minus 1 only in the previous index only. If the index is equal to word dot length minus 1, and okay, this one I think I can have it above. If it is invalid, this one I can have it above all. Now if index is equal to word dot length minus 1, and I need to check if the character at the current index is the last letter in the word, last character in the word also, then I think I can just return it as true. Or board ij contains the same character as the last character in the word, then I think I can just return it as true. I don't have to check any neighbors or do any more traversals. So I know that I can just return it as true then. So let's take this one there to make it easier to check. Okay, current char is equal to word dot char at index. So index is word dot length minus 1. If index is equal to word dot length minus 1 and current char is equal to board of I dot j. Okay, then we can just return it as true. Okay, we can, another thing we can do is if the board of I dot j not equal to the current char, we are checking that one. Then we are returning it as false. Then we can, that knows that board of I dot j is equal to current char. That means we can just, we don't even have to make this check also. We can just check if the index is equal to word dot length minus 1, then we can just return it as true. We don't have to check any neighbors or do any more things after that. So yeah, this looks good to me. Let's run it and check once. I am skeptical about this syntax though. Okay, that syntax is fine. So ABCD. For ABCD, we returned it as true and the expected value was false. So basically I'm returning it as true for everything. So what's the catch? So I'm returning it as true for everything. Okay, let's check this example only. Take this example. I don't want to write it again. A, B, C, D, E. First we will go through A, which is 0, 0. So I is equal to 0, J is equal to 0. Current char is equal to board of 0, 0. That will be A. And then, okay, let's go through this example. Negative case only. Okay, first character is A. Okay, I'm kind of skeptical. I was thinking about this check I made. If index is equal to word dot length minus 1. If index is equal to word dot length minus 1, I'm returning it as true. Yeah, I don't see anything wrong there, at least as of now. So I came across A, B, and C for sure. And then I've been incrementing the index. Index is equal to index plus 1 I passed, and I passed as that direction, and J I passed as direction of 1. Okay. So I incremented I and J value, and I incremented the index value also. So now here I am checking word.char index is current char, and board of ij is not equal to current char, then I'm returning it as false. Okay. I'm just printing the index here just to help with my troubleshooting faster. So we can see here 0, 1, 2, 3, 3, 3. Okay. Here another thing is we need to check the visited before this one. If it's already visited, we should mark it as false. If not valid, then return false, and if visited of I, I and j, then also return it as false. This should be R. Either not valid or visited, then return it as false. Okay. So that makes it work. So what was the mistake then? Okay. The mistake was ABCB. Okay. ABCB is the word that we are looking into. We found A here. Okay. And then we asked to do the depth first traversal. And then we came here, first character index is 0, and then we did 0 and everything. We found A, and then next neighbor could be this one. Okay, this returned false because S is not equal to B. Next character index is 1 now, so I'm checking that character is not equal to S, so I return false. Okay, and then we didn't return false. I'm looking for the next direction. Next direction is like on the left side of A, that is invalid, so I returned false in the beginning only. And then here top direction, that is again that return false in the beginning only. And then the right direction, which is B, in the B it returned true now, because it can match with the character. It returned true. That's why I'll do I won't return true. This doesn't return true. Basically I did the DFS traversal with B again. Since it satisfied all these conditions, it passed till here. And then I'm passing the next index. Index is equal to index plus 1. Index is equal to 2 now. I'm looking for C. So all the other directions of B didn't work. This direction worked. Okay, C. Now this one worked. Now what I was missing was from C, I'm making the same checks, but I had not marked, I was not checking for the visited. So if I didn't mark the visited, like I was marking this A as visited, B as visited, and C as visited. And then from C, I'm looking for the next character B with its all 4 neighbors. So it could be this one neighbor, and top one neighbor, which is invalid, and then the left one neighbor. Since I did not mark this as visited, it was considering this also, and A, B, C, B, it was returning it as true. Now since I am checking if this is visited, already visited once, then return false. Now it is just returning it as false for this case. Before that, it was returning it as true. So you can see now it is returning it as okay. I think it will traverse only until here. Travel only. Okay, I can remove my print now. Okay. Okay, we can see here for test case 3, ABCB, it's returning false. If I just remove this remove this visited, it will return true for this one also, because ABCB, it is finding ABCB here, ABCB. So you can see here, it is returning it as true. My logic is returning it as true, whereas the expected value is false. That's why let's keep the or visited check also. Now it works. And let's submit this. Okay, this one works. So this is another graph traversal. So I hope everybody understood this one. Let me know if you have any questions about this. Otherwise, we can move on to the next problem. So before the next problem, let's take a small break and then we can proceed to the next problem. In the meantime, if you have any questions, please let me know. Okay, let's get to it. Let's get to the next problem. We have to go through 2 more problems in this session in order to complete the agenda that we thought of in the beginning of the session. So we are done with the word search and search in the rotated array in the previous session. Let's start with the next problem now. Product of array except self. So LeetCode 238, product of array except self. It's a LeetCode medium problem. Given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. Okay, you must write an algorithm that runs in O of n time and without using the division operation. Okay, so here without using the division operation, we should run it in O of n time. So the basic approach, let's see if we have taken anything like nums here. Okay, so how would we think about this one? Okay, 1 2 3 4. If that is the case, we will go through all the other numbers except for self means, okay, 2 cross 3 6, 6 cross 4 24. We will write it as 24. And then for 2 again we will check the other ones. 1 cross 3 3, 3 cross 4 12. So 12 will be the second one. And then for 3 again, 1 cross 2 2, 2 cross 4 8. So 8. And then 1 cross 2 2, 2 cross 3 3 for this one. 2 cross 3 6. Yeah, so 6. So this would be the output, right? But it took O of n square. When I just did this one, for every character I went, or for every number I went into the other numbers and then I did a product of those numbers. But the requirement is to solve this problem in O of n. How to go about it? How to do that in O of n? Let's see. This is I think I know this one because I might have seen it sometime long ago. It is like we will create, okay, every, like with a single pass. Okay, so now we will initiate a product till now as one of the variable. Okay, that will be 1. Product till now means product until now. Okay, product until now is 1. Okay, we will just multiply the current value with that one, product until now, and we'll return it as 1. Not the current value, we will just emit it as 1. For the second one, okay, for the second index, we won't consider the second index, right? Product until now is all the values of all the indexes before this one except this index. So all the indexes before this one means product until now was 1. Let's do 1 cross 1. Okay, that is 1. And then product until now would become 2. No, product until now will be 1 only. Okay, now left for the third or second index 2, here let's do like index minus 1, nums of index minus 1 multiplied by the product until now. So product until now is 1 and index is 2. Okay, let's do 2. and then 2 cross 3, that will be 6. Okay, 1126. Let's see. I'm also not very sure if I'm doing right. Let's see if we can come up with a solution for this one now. Okay, now for this one, let's go from backwards now. Let's iterate from backwards. Okay, for this one, let's initialize it as product as one of the variable. Okay, so now here, whatever the value here, existing value, 6 cross 1 will become 6. And then what shall we do? We should do product is equal to product star the current index, like num at current index. So that will be 1 cross 4 is equal to 4. Now product is equal, now for this index, this one is equal to product star the current value. So 2 cross 4 will become 8. Now product will be is equal to product star current value, 4 cross 3, 12. Okay, now here this one will be is equal to current value multiplied by 12, that will become 12. Now product will be equal to product star current at num, so 12 cross 2 is equal to 24. Okay, and then now here product star whatever the current value is, that will become 24. So 24, 12, 8, 6. This is the right, is this the right value? 24, 12, 8, 6. Yeah, this is the right value. So we did 2 iterations for this one. One iteration in the forward direction and one iteration in the backward direction. So it is O of 2n, which is logically O of n. So that satisfies the condition. We didn't use division operation, or we didn't do it in O of n square. We were able to solve it in O of n with this trick. I would say it as a trick. I don't prefer asking these questions in the interviews because this purely depends on one's preparation, I think. But yeah, there is some logic also, like we can come up with, okay, product of array except itself. So we will be kind of trying to get to the product except itself from the forward direction and backward direction. But yeah, it takes a while if someone who hasn't seen this problem, if he has to devise this algorithm. I mean, it's definitely not like one of the question asked out of 3 in an hour. It would definitely take a complete hour for someone who hasn't seen this problem to solve this one. So let's see how to implement this. So now let's say if I do not have this in front of me, I will get confused too, because I do not know the exact method. So I will look into what I did, the approach now, and then I'll implement it. Usually, usually that's how you should go about it. First, try to clarify the approach before starting to implement for these kind of trick implementations. Or these kind of tricks. I'm calling it as tricks because this is a kind of knowledge required to come up with this algorithm or a logic. Okay, so int result, let's say it as result is equal to new int of nums.length. Okay, and then how to solve this one? I did for int I is equal to 0, I less than nums.length plus plus. Okay, I'm looping through that, and then before that I need a product is equal to 1. I instantiated a product as 1. So now for every so I can start iterating from I is equal to 1. First one will be 1 anyway. So now here result of I will be equal to result of I is equal to what did we do? So it is num of I minus 1 multiplied by product. Num of I multiplied by product multiplied by probably result of I minus 1. Let me see how this one would work. Nums of I minus 1 multiplied by result of I minus 1. instead of product, and then for that result of 0 is equal to 1. Okay, so what would this one yield as output? Let's see what this one will return, or we can just return result and check. Okay, we're still halfway, 1126. So now we are in this state we implemented till now. Okay, so now the next step is to return the rest of the thing. So int product is equal to 1. We did not need this product before. What I did was I just initiated a result of 0 is equal to 1, and then result of I is equal to nums of I minus 1 star result of I minus 1, and I started iterating from index 1. If you notice this one, I didn't start from 0, because if I take 0 and if I'm looking for I minus 1, then it will be invalid. So now, as I said, I will be traversing from the last or from the end. For int I is equal to nums dot length minus 1, I greater than or equal to 0, I minus minus. Okay, and now result of I is equal to result of I star product. Okay, so now result of I is equal to result of I star product. And then why did we do that? Because, and I initialize product as 1, because we know we were calculating product till now for all the elements in the first loop. For the last one, we calculated product till now, like, which is 2 cross 3 6. So we know that for the last index we already have the result in place. We just multiplied it by 1. We just have to multiply it by 1. Okay, now the product would become this one. Product would be equal to, actually, not result of I cross this product, but yeah, result of I cross product. So product should be is equal to product star result of I, or product star nums of I, product star nums of I. So product will be, for the product, I keep multiplying it with the nums of I every time. So now I will have the value from right side also. Like, for example, for this, whatever was stored in the result here was the value from, like, was the product of all the left hand side elements. So it was 2, right? Like, all in the index 2 here, the product of all the left hand side elements was 2. So that was stored in the first array or the first iteration. Now from when we are iterating behind from the end, what we are doing is we need to get the product of all the elements until now from the end. So product of all the elements until the end, how do we get that? Product is equal to product star num of I. Product star num of I will get 4. 4 cross 2, 8. Now 1 cross 2, 2. 2 cross 4, 8. And just it is the product of all the elements except for this element. So once we did from 0, and once we did the product from the last index. So product is equal to product star num dot I. Okay, that should give us the proper output now. So we can see here 24, 12, 8, 6, and the same thing for this one and the other example. Let's submit it and see if we addressed all the edge cases also. Yes, this looks good. We can just leave it as it is, or we can just remove this commented code. Yeah, that gives the solution. That's it. I think if we know the approach, this is a kind of easy problem to implement. But if we do not know the approach, it is hard to come up with the approach on the spot, even if we know the data structure well and algorithms well. So yeah, that's about it. Let's see. Let's move on to the next problem now. If anybody has any questions, I didn't check the. Okay, I think there are no messages. Let me know if anyone has any questions about this one before I move on to the next question. I'll just wait for a minute now. Okay, awesome. So yeah, this is a easy problem. I hope there is no questions about it. So next question is binary tree maximum path sum. So this is also kind of the previous problem. I have solved it before. That's why I'm able to come up with this approach pretty fast. I have seen this problem before. So otherwise this could become a little bit tricky in order to think about it, even if we know the tree data structure very well. That's why it is marked as hard. I would say the approach is hard to come up with, but the implementation should be easy if we know the approach well. So let's see how to go about it. So okay, uh, let's let's start with this one. Okay, let's start with the question. Lead LeetCode 124 binary tree maximum path sum. It's a LeetCode hard question. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. Okay, a node can only appear in the sequence at most once. Okay, note that the path does not need to pass through the root. Okay, path does not have to pass through the root. The path sum of the path is the sum of the nodes value in the path. Given that the root of root of the binary tree, return the maximum path sum of any non-empty path. So here, if this is the tree given, they would have given the root. The maximum path sum is the total of these three: 2 plus 1 3, 3 plus 3 6. That is kind of obvious. Let's say this is the tree given, and this is the root given. And then if we consider, okay, if we consider this root anyhow, okay, that would add a lot of negative value. Even if we consider this 9 minus 10 is equal to minus 1. And then whatever we add on the left side, like minus 1 plus 20 is equal to minus 19, minus 1 plus 20 is equal to plus 19, plus 19 plus 15 plus 34. So this is not the maximum path sum. If we just do this 20 plus 35, it will be equal to 20 plus 15, 35. 35 plus 7, that would become 42. So that is the maximum path sum. How to come up with the maximum path sum if we know just the reference for the root element? So for that, for every node, let's compute what's the maximum path on the left side of the root, or left side of the node. For every node, let's do the same exercise. What's the maximum path on the left side of the node, and what's the maximum path on the right side of the node, and then see, okay, if the what is the, like, if is there a max, let's say one of them is, or two of them have negative values, then it does not make sense. If this one is minus 10, and if this one is minus 9, then definitely whatever the maximum path comes from the right side, that would be the path, right? That would be the maximum path. We don't have to include these nodes if those are negative values. Those are not going to add any value. But if this is a positive value, whatever the path comes from this one, like let's say this is 15 and 10 and 20, and this one, let's say this one was not negative 10, if this one was a positive 10, okay, I'm assuming this is a positive 10, then what it would have been? It would have been like, from 10, I would say, what is the maximum path in the left, left child. So from the left child returns it as, okay, maximum path sum is 9. From right, it would return what's the maximum path sum. From the right child, the maximum path sum is either just this value. It can be either just this value because this could be negative. This could be negative 15 and negative 7. So this alone could be the maximum value, or sum of the node and this one could be the maximum path value. Okay, 20 plus 15. So that is 35 could be the maximum path value, or 20 plus 7, 27 could be the maximum path value. So here now, as per the example given here, so 20 plus 15, if we need to connect it to the above node, we cannot include these three, all these three. We can just include these two or these two. So what we return is the maximum of either these two or maximum of these two or just this value, maximum of those three. Either maximum of just this three, just this value, or sum of these two or sum of these two. So now in this case 20 plus 15, 35. This would return 35. And then if this was a 10 plus 10, then 35 plus 10 would become 45. 45 and then this one was 9. It would include this one also and add the sum. Left sum was 9 and then right sum was 35 and then current value is 10. 35 plus 10, 45, 54 the maximum path was. That would have returned it. Now in this case, maximum path, for the maximum path, even though it returns 35 here, when this one asks, this node asks what's the maximum path to the left child. So it says 9. And this one asks what's the maximum path in the right child. So in the right child, we come here, we compute the maximum path here. So this one also asks what's the maximum path in the left child. So it tells 15. What's the maximum path on the right child? It says 7. Now this one has to compute what's the maximum path using this node. Like what's the maximum path that can end with this node, including this node only. Like that can end with this node is 20 plus 15, 35, 30 plus 35 plus 7, 42. But 42 can't be returned to this 10 because I'm using all three nodes. So this itself is a path. Path cannot be like this. Okay, if we connect both the edges here, left and right, I can't return that value as a path to its parent. So this is the value that should be stored. If 42 is the maximum value, if it is overriding some centrally stored maximum path, then I can override this. Okay, but while returning to its parent, when its parent asks what's the maximum value in you, it will return either its own value, maximum of its own value, which is 20, or maximum of 20 plus its left child, 20 plus 15, 35, or 20 plus 7, 27. So it will return 20 plus 5, 15 in this case, 35. But again, if it combines with the current node, that won't help anyway. And this one combined with the left child, that won't help anyway. So we will end up with having this value itself as the maximum value, combining this node and its left child and right child. So how to do that? Let's see. Let's implement this one. So first thing is, let's have a recursive method. Let's add a recursive method. Okay. Max path sum recursive, let's call it plainly max path sum recursive, and let's call it generically as node, since we will run it for every node, not just for root. Okay, private okay, and this should return, sorry, this I'm passing root to this one, but here I'm calling it as node. Okay, and what this should return, this should return the maximum value from this node. Okay, so now let's see, if the node is equal to null, then its maximum path is just 0. It will just return it as 0 without anything. Okay, so we can assume that as the base case. Now if node is not null, then let's calculate the maximum path of the left side. Okay, left path, let's assume it as left path. And how to compute the maximum path? Let's call this recursive method and node dot left. Okay, and let's compute the right path also in the same way. Okay, and we are computing the maximum path sum recursive of right path as well. Okay, now current value. Current value also we know that node will have a current value as -10, let's say. Okay, now we took the maximum path, the left path came as 9 and right path we added, and then the right path, it has its own recursive function called, that is again calling its left path, it returned as 15. Okay, and then it called its right path, it returned as 7. Now it has to return, while returning, math.max of, as I said, it will be either the current node value, node.value, or the math.max of this left path or right path plus node value. So this is what we would return to its parent. What is this? Either we will just return the value of the node itself, or the maximum of node plus left value, or node plus right value. So that is what we will return to its parent. Now, okay, now this is all done. Okay, we can return the best path from here. So this is the solution for finding the maximum path, including the root node. Okay, if we need to include the root node and find the maximum path, this would work. But now we found the maximum before coming to the root node or the parent itself. Like here only we found the maximum path. In these kinds of scenario, rather than just depending on the returned value, what we need is we need a kind of central or a shared int max path sum for the return value. We will initialize it to integer.min value. Okay, and here the value of that one, max path sum, will be is equal to either math.max of either max path sum itself, or the maximum here, basically current maximum. Let's take it as current maximum. Okay, let's take this as current max, and we can return this as the current max. Okay, and here max path sum will be is equal to either the max path sum or the current path sum. Okay, or the current path sum. This can be current path sum. Okay, so that then we will replace the max path sum also in that case. Like this will be, okay, I think I have missed something. So in this one, current path sum, I'm just checking the node dot value or maximum math.max of left path and right path and node value. But there is another thing is left path sum, right path sum, and plus node value. Both of this plus node value. So that is one thing I have missed here. So let's take that also into consideration. And here max path sum is equal to math.max of max path sum, comma, this is current path sum. Another one we can current path to parent. Let's mark this as current path to parent and current max sum. Let's make this as 2, current path to parent or current max to parent. Okay, let's return the current max to parent here with no confusion, and current max sum would be is equal to math.max of current max to parent r left path plus right path plus node dot value. Here maximum of left path or right path plus node dot value. Here left path plus right path plus node dot value, all three. So that is the current maximum. So that is, I can just do this only once here. So this should give us a comprehensive solution. I'm rewriting the max path sum here, and at the end I can just return the max path sum which we had centrally. Let's run this one. Okay, syntax. Okay, now we can see this one is accepted for all the inputs like 1 2 3, which is of this case, and case 2 is okay, it is this one minus 10 9 20 15. Okay, and case 3 is 2 comma minus 11, only 2 nodes, and 2 comma minus 1 minus 2, there are 3 nodes. It works for all these use cases, all these test cases. Let's run this and see if there are any edge cases in this one. Okay, this one works. Okay, so I think I explained in detail why we took max path to parent, and okay, description, how to go to the, like, why we took this max path sum and why we took this left path and right path sum and all these things. But let me know if you have any questions about this one. So yeah, I assume there are no questions about this one. So we are done with the mostly the problems that we planned for the current session. I see Shaker had a couple of comments here. Yeah, Shaker, uh, I think, yeah, I would want to share my experience. I made this channel as kind of a journal for all my technical learning, so that I can stay myself accountable as well. Like now with this one, it's not just helping others. I obviously want to help others as well, but with that, it's helping me as well indirectly to at least that satisfaction it gives. Like thinking that okay, it helps someone, that helps us in a different way. So that's the main goal. But yeah, like with time I'll try to share my experiences. That journey and experience might help as well for somebody who is in the same path or trying to do the same thing. Just I worked at AWS for a long time. I worked at AWS for close to 6 to 7 years, and then I worked at a couple of different companies. That's mainly about my experience. I've been working mostly as a backend engineer, working on the server side or um, distributed systems and server side development. But other than that, yeah, nothing specific. I'm in the journey as anybody else, and I'm learning every time. I need to learn as well. I can just like I was tired of people or the influencers who just show off as if they know everything, and like that will be like the brushed up information that they curate behind the scenes, right? Like nobody is perfect. I wanted to expose that vulnerable side of the software engineer. So this is good. You're asking for that. Like I can definitely share about my experience. But yeah, like as of now, since I'm kind of working on the materials to prepare for, which helps to prepare for the interviews. I'll try to continue with that until at least first thing is I need to complete that blind 75 and few system designs. And as you asked, I'll try to uh, create few basics courses about object oriented programming and solid principles and those kind of things. After that, I'll try to, once I have enough audience having interest, I'll try to share my journey and other experiences. But yeah, if you want to know anything, please feel free to reach out to me. I'm happy to talk to you, and also I'm happy to help you plan on any of your preparation or any of your studies uh, or any questions that you have about your career. I'll be able to answer that. yeah, that's about it. I hope this was useful. This session was useful. Let's meet again in for now. Let's meet again either tomorrow or maybe if I still have energy. It is 8:43 p.m. today here in the local time. So if I still have energy left, I'll start another session like in an hour or two. Otherwise, I'll meet you guys tomorrow, and I'm happy with the turnout. I can see a couple of regular faces. I'm hoping to create more content. And if you people have any questions or anything, uh, you can email me directly at my YouTube channel name at gmail.com, or you can post it in the comments as well. I'll make sure to answer those things. Thank you very much. Have a good night. See you.